All right, everyone. So our next task is going to be figuring out, how do we change this angle to get it to extrude kind of outward from where it is, okay? And most of you already sort of figured out the easy way of doing it, which is to just change the direction of the extrusion. So this extrusion right here, and we'll do just what Janet did here a second ago, and we're going to change it to unit. In my case, I'm going to do Y.
Y?
Yeah. It just depends which way your surface is facing, really. So I can just take one of these and go to each one. Go down there. This goes up there.
Is there an easy way to replace those?
This is the easiest way as far as I know. I wish I could just right-click and change it to be Y instead, but yeah. So that's Y. And I can, extrude these, make them, more shallow, whatever you want to do with them. It's up to you. But the point I kind of want to make about this is that while some of them are extruding kind of nicely, like I can see a pretty good amount of definition in these right here, some of them are not, like this one, right? It starts to taper off to be more of like a wedge shape, right? And that's not really what we want to do. So, for this exercise, what we're going to do, and I'm just going to draw a quick, tiny little mini diagram on the board. We're going to find a center point on each one of these surfaces and measure where the normal is, and then we're going to extrude in that direction. Okay, so that's going to be a little bit cleaner for us for this exercise. Does that make sense, that diagram?
Yeah.
Okay, but we need to kind of rebuild it a little bit. Well, we'll start by just using the actual surface itself in its curved form, and then we'll transition it to be a flattened form later on in the class. But let's start with just each one of these individual surfaces. Okay, we need to find the surface normal. Okay, and this was, like I mentioned, it's like the Holy Trinity. When you're finding the surface normal, the names of the commands are not super intuitive. It's just kind of like this wiry mess of a bunch of things that you should probably just save and keep and know. Eventually, I'm going to show you how to make a custom component out of it, but I want you to practice building this a couple of times so that you really understand what's happening before we do that. Okay, so let's do it together. To find a surface normal, you're going to operate off of each of the surfaces themselves. That's this one right here. Okay, you'll need to go into surface and analysis, and there are 3 components you need every time you need to do this. You're going to need area. And what area is going to do when you plug surface into that, actually, let me hide these. Yeah, I'm going to hide those. Everything that's happening at the end, just hide them. Yeah.
I have a quick question. I didn't hear. So, why did you change from unit Z to unit Y?
I chose Y because X would have had everything extruding this way, and it wouldn't have been easy to see like what's going on.
So it's just how you make your curve.
Yeah, it depends which direction it's facing. Z is going to go up from the origin, X is going to go to the right, and Y is going to go 90 degrees from X.
Okay.
Can't say up anymore, but yeah. Does that make sense? Yeah.
Can I just like rotate my curve then and don't have to change?
Yeah, you could do that too. Yeah. All right, so what does area do? It creates well, its purpose is to calculate how much area there is in each of the surfaces that you plug into it. But it also calculates where the centroid is on that surface, right? Because you need to find a centroid in order to find area sometimes, or at least it is a byproduct of finding the area. So that happens to live here. I wish that there was just like a centroid command, but whatever, it's there. The other two we need are evaluate surface and surface closest point. And I'm going to drop them both in here and then explain kind of what's happening. All right, and this is the configuration I typically put them in. But so surface closest point, it says that it finds the closest point on a surface. It just so happens that this centroid already is coincident with that surface, so it's just passing that information along, saying this point to this surface. And so the centroid is going to plug into the point input. That's this. And then the surface is going to plug into the S input. It's getting a little messy right here on that surface output, huh? I'm going to show you some shortcuts to clean that up too in a little bit. So now evaluate surface is, or rather I should go to the export, or the output here first. You don't have to worry too much about this. This is just passing more information out that kind of already exists, like the point itself. And then it could also measure the distance between the point and the surface, which in this case is pretty minuscule. This won't always be exactly on the surface. You just kind of need to know that. It won't always be exactly on the surface. But the UVP, that's measuring where along the UV axis that point lives. Right? So that's like the XY of that warped surface. It's saying where is this point? And that's because when I use evaluate surface, what it's going to do is, well, this says local surface properties at a UV coordinate. So this gives us the UV coordinate, and then we say, I'm going to evaluate this surface at that UV coordinate so that I can get this information. And it's going to output, the point output is just passing along points again. The F output is for frames, otherwise known as planes, right? And then the N output is the normal vector. And in this case, the vector only has direction, no magnitude. But UVP gets plugged in here, and you probably could have guessed that surface is what gets plugged in there. And you're going to see these little frames show up. And now we have our normal vector to extrude along. Okay, so I'm probably going to need to give you guys a minute or two to catch up before we go on, but I'm going to stop this video if there are no questions.